Okay, here we are together again. Now we're working in section 2.1 and we're going to work on the distance and midpoint formulas. First of all, I'd like for you to look with me on page 152 underneath figure 6 is a reminder that if you need to find the distance, the length of a horizontal line, you can just subtract the x coordinates, and if you need to find the length of a vertical line, you can just subtract the y coordinates. So what we're about today is how do you find the length of a line that is not vertical and not horizontal. The formula, which is derived from the Pythagorean theorem, looks like this: x2 minus x1 squared plus y2 minus y1 squared. Alright, so the problems that we're going to start with are on page 155, and I'm going to start with problem number 19. It gives me a picture and it's asking me to find the distance from the point 0, 0 to the point 2, 1. So I'm going to label this x1, y1, x2, y2. And then it's just a matter of substituting into the formula and simplifying that radical. So my formula says x2 minus x1 and square it. So I'll do 2 minus 0 and square it plus y2 minus y1 squared. So y2 minus y1, ooh, that's a minus, not a comma, sorry, squared. So 2 minus 0 is 2, and I'm going to square that. And 1 minus 0 is 1, and I'll square that. So that's 4 plus 1, which is the square root of 5. Now, I will caution you here, when you have a radical, you cannot take the square root of this part and the square root of this part and add them together. That's not a legal step. You must add them together first, and then if you can, you simplify the radical. So that's the distance. Now, that might not have a lot of meaning to you as the square root of 5, but what it means is that the distance is about 2.1. Now, I want to show you graphically what that means. If I can figure out what I did with my graph paper. Here it is. Alright, so the point they gave us was 0, 0, and the point 2, 1. And they wanted us to find that length. So what the distance formula does is says if I take the length of this line, which is right here, and measure it on the scale that I have on this paper, it's going to be a little bit more than 2. See right there, it's a slightly bit more than 2. Well, that's what the square root of 5 is. It's a little bit more than 2. So it allows us to find the distance, the length of a line. The length of the line, distance between 2 points means the same thing, as if it were laid out on a scale that we could actually read. So the next problem is number 21. And the points that I'm given are negative 2, 2, and 1, 1. Now, it doesn't matter which one you write first. It's like saying the distance from Brunswick to Savannah is the same as the distance from Savannah to Brunswick. So that which ordered pair you write down first doesn't really matter. But I'm going to leave it in this order and write x1, y1 and x2, y2. And then it's just a matter of substituting those values into the distance formula. So x2 minus x1 squared plus y2 minus y1 squared. Now notice right here on the x part, when I do 1 minus negative 2, that's going to become a 1 plus 2, because a negative times a negative is a positive. And then 1 minus 2 is a negative 1. So 1 plus 2 is 3, and 3 squared is 9. Negative 1 squared is 1. I add those together and get the square root of 10. So the square root of 10 is slightly more than 3. If you type that in the calculator, the square root of 10, it would be like 3.1, which means if I could take the length of this line and lay it out on a scale where I could read it, it would be a little bit more than 3. Now, these two had a graph to go with them. It's not necessary to have a graph. It's helpful to just kind of have a visualization, but it's not absolutely necessary to see the graph. For example, in problem number 23, they just give us 2 points. And we're supposed to find the distance between them. So we'll call this x1, y1 and x2, y2. And we're just going to put the numbers into that same formula that we made reference to. So that's going to be x1 minus x2. I said that backwards. I'm sorry. x2 minus x1 squared plus y2 minus y1 squared. So again, we have that 4 minus a negative. So that's going to become 4 plus 4. Two squared is 4. 4 plus 4 is 8. And 8 squared is 64. And I add those together and get the square root of 68. Now, we always need to be thinking about, can I simplify the radical? The first two I had was the square root of 5 and the square root of 10. And those can't be simplified. But the square root of 68, if you make a factor tree for that, it's 2 times 34, and the 34 is 2 times 17. What I'm doing is just breaking it down into factors, and I'm circling the ones that are prime, that is, that cannot be broken down anymore. So this becomes 2 times 2 times 17. And the rule is that if we have a pair of like terms, we can pull that out. So 2 times 2 tells me I'm going to put a 2 out here. And then what's left under my radical is the square root of 17. Alright, I'm going to move on down to number 27. And my points are 5, negative 2, and 6, 1. So x2 minus x1 y2 minus y1. Okay, here it is again. 1 minus a negative 2 is going to become 1 plus 2 because of minus a negative. 6 minus 5 is 1, and 1 squared is 1. 1 plus 2 is 3, and 3 squared is 9. So I have the square root of 10 again, which cannot be simplified. So those are our examples for using the distance formula. That is, finding the distance between 2 points, or finding the length of the line segment that connects those 2 points. The next part of the exercises in this section, if you look with me above number 33 where it has the directions, it says to plot these points, plot each point and form the triangle, show that the triangle is a right triangle, and find its area. Alright, so that's a lot involved. Let's just see what this is saying here. Let's see if we can get back in focus. Okay, so I'm on problem number 35, same page, and I'm given the point negative 5, 3. 1, 2, 3, 4, 5, 1, 2, 3. That's this point. Then I'm given the point 6, 0. 1, 2, 3, 4, 5, 6, 0. Let's see, this was A and this was B. And then I'm given the point 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, that's the first thing it asked me to do, was to plot the points. Then it tells me, this is C, not 5, to draw the triangle. Okay, now I can see from the picture that it's a right triangle, but you can't use that to prove it. What we're going to have to do is to show that it meets the conditions of the Pythagorean theorem. It might be helpful for you to look back on page 153 and read through example 3. That's the process that we're going to use. So I'm going to take my regular paper and I'm going to find the length of AB, BC, and AC using the distance formula. So I've got to use the distance formula 3 times. I'm going to start with the distance from A to B. Well, that's negative 5, 3 to the point 6, 0. Same distance formula. X minus a negative 5 is going to become plus, and 0 minus 3. Six plus 5 is 11. Squared is 121. 0 minus 3 is negative 3. Squared is positive 9. Add them together and I get the square root of 130. Now, it's true that that can be simplified, but I don't have to simplify it. Well, actually, it can't be simplified. It's 13 times 10. That won't work. But even if it could be simplified, it's okay to leave it in its unsimplified form for the purpose of what we're doing. All right, now I'm going to find the length from B to C. Point B is 6, 0, and point C is 5, 5. So the distance is X minus X squared plus Y minus Y squared. 5 minus 6 is negative 1. And 5 minus 0 is 5. Negative 1 squared is 1. 5 squared is 25. Add them together and I get the square root of 26. Okay. Now I'm going to find the length from A to C. That's my third line. And that's going to be negative 5, 3 to 5, 5. So the distance is x minus x. 5 minus a negative 5 will become 5 plus 5. And 5 minus 3. Five plus 5 is 10. 10 squared is 100. 5 minus 3 is 2. 2 squared is 4. So that's the square root of 104. Now, you remember from days gone by that the Pythagorean theorem is a squared plus b squared equals c squared. C is always the hypotenuse, and it's always the longest of the three sides. So I've got the square root of 130, I've got the square root of 26, and I got the square root of 104. Well, clearly this is going to be the longer side because 130 is larger than the other two. So that's going to be my C. My A and B can be either one of these. It doesn't really matter. I'm going to use the square root of 26 here and the square root of 104 here. Now when you square a radical, you just get the radicand. So the square root of 26 squared is just 26. Whoops, you can't see that. And the square root of 104 squared is just 104. And the square root of 130 squared is 130. Well, 26 plus 104 is 130. And since that equals 130, by virtue of the Pythagorean theorem, I have shown that it is a right triangle. Because if the sides of a triangle satisfies this statement, then it has to be a right triangle. The next part of the problem asks me to find the area. Well, you remember that the formula for the area of a triangle is 1/2 the base times the height. Well, how do I know where the base and the height are? The base and the height are the two pieces that form the right angle. That's this part and this part. The two pieces that form the right angle, that's called the base and the height. I know it doesn't look like y'all are thinking that the base needs to be on the bottom. Well, you could turn it around and do it like this if you wanted to. But the point is, the two pieces that form the two legs of the triangle form the base and the height. So the part that's not the hypotenuse is the part that forms the area. So it's going to be 1/2, and the two sides that I had that were not the hypotenuse were the square root of 26 and the square root of 104. And so I need to multiply 26 times 104 because I can multiply underneath a radical. And I get the square root of 2704. Now, it doesn't tell me in the directions how I need to simplify that. So I'm going to guess that they want me to put it in simplest radical form. So I'm going to come over here. Well, I know that that's 26 times 104 because that's where I just got it from, was multiplying those two numbers. I know 26 is 2 and 13, and neither one of those can be broken down anymore. I know that 104 is 2 times 52, And 52 is 2 times 26. And 26 is 2 times 13. So I have 1, 2, 3, 4 twos. 2, 2, 2, 2. And a 13 and a 13. Well, let's see what happens. I have a pair of 2s, so I'll have a 2 on the outside. I have another pair of 2s, so I have another 2 on the outside. And I have a pair of 13s, so I have a 13 on the outside. So 2 times 2 is 4, and 4 times 13 is 52. And notice that there's nothing left under the radical, so that's just my answer. Well, if I had thought about it before I did my factor tree, I could have just typed in the square root of 2704 to see if it was a nice, pretty number, and indeed it is. It is 52. So I come back to this paper. I know now this square root is just 52, and 1/2 of 52 is 26. So that's my answer for the area. Now, the fact that this 26 and one of the sides of a square root of 26, that's purely coincidental. Don't assume that that's going to happen every time, because it will not. Alright, so let's review that just one more time. What did we do? We found the length of 3 different sides, A, B, and the 3 different sides, A, B, B, C, A, C. We knew the longer one had to be the Pythagorean theorem. We took the other 2, squared, 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 and squaring, all it does is remove the radical, and showed that I got a true statement. And then I did 1/2 the base times the height to find the area. That was all the parts of that triangle, or that problem rather. And again, there's one worked out just like that on page 153, example 3, if you'd like to look at that one. The last part of this lesson is the midpoint. And when you think middle, you should think average. So midpoint, if I'm given 2 points, x1, y1, and x2, y2, and I have to figure out the midpoint, then I'm just going to average. I'm going to do x1 plus x2 divided by 2, and y1 plus y2 divided by 2. I'm averaging the x coordinates, and I'm averaging the y coordinates. That's going to be our formula for midpoint. Alright, so let's look at an example problem. I'm still back on page 155, and I am at problem number 39. My points are 3, -4, and 5, 4. So my formula tells me to add the x coordinates together and divide by 2, and add the y coordinates together and divide by 2. Well, 3 plus 5 is 8, and -4 plus 4 is 0. 8 divided by 2 is 4, 0 divided by 2 is 0. So I'm claiming that this is the midpoint. Now, what does that mean graphically? It means that if I plot the point 3, 1, 2, 3, 1, 2, 3, 4, 3, -4, and the point 5, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, I'm looking for the point that's in the middle, and I'm claiming that that point is 4, 0, 1, 2, 3, 4, right there. Well, you can see that truly is halfway between those 2 points. Now, I realize that when you're doing your homework, you can just click on check my answer to see if that's right. But when you're doing a quiz or a test, you might want to make a little quick sketch. It won't tell you for sure that your answer's right, but it can tell you for sure if it's wrong. For example, if I had done my math and got a point that was way over here, claiming to be the midpoint of that line segment, then I know I had done something wrong. So a graph will help you verify that your answer is reasonable. All right, let's do one more in this group. I'm going to do number 43. The points are 7, -5, and 9, 1. So the formula tells me to add the x coordinates and divide by 2, add the y coordinates and divide by 2, which just means I'm finding the average of the x's and the average of the y's. 7 plus 9 is 16, divided by 2 is 8. -5 plus 1 is -4, divided by 2 is -2. So this time I'm claiming that the midpoint is 8, -2. I'm going to go back to my graph again just to see if that's reasonable. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So this is my first point. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. That's my second point. So when I find the midpoint, it better be right in here. If it's not, then I've made some mistake. So let me see. I have it as 8, -2. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. That looks pretty good to me. So that's how you can check your answer if you're not on My Math Lab. So the answer is that it's the ordered pair 8, -2. The question is find the midpoint, and the midpoint's going to be an ordered pair. Now, because it is an ordered pair, be sure you put it in parentheses because it needs to be in parentheses to be an ordered pair. Alright, that's the end of this lesson, and that's the end of the assignments for week 2. So any additional things that you see come up on My Math Lab after 2.1 will be things for week 3, where I'm just trying to get a little bit ahead of you. So you know what my number is, you know my email, call me as you need help. Bye.